Thanks a lot, Ivan. It's really nice to see so many people, especially after the concert and and a very long Phosphor-G with plenty of interesting things. So we will talk about advanced visualization, so about Deck.gl, about MapLibre, about when to use what, and our experience on that. And I hope you can get some tips and tricks for it. We are Geomatico. For the ones who don't know us, we're a cooperative. These are the main partners. So here we have Francisco, that's the only one who's here, somewhere there. And we have Oscar, that's our CTO, who is the guy who should be doing this presentation probably, but it's and the rest of the partners. We're a cooperative, so if you are interested in how an IT cooperative works, that's not so usual. Please ask. And what do? We do custom GIS web development. We do a lot of web development for many years. We come from the SDI, OGC, WMS standards, like we're experts on PostGIS, GeoServer, blah, blah, blah. And now we're doing more advanced visualizations. What do we mean by that, advanced visualizations? This marketing words, advanced, is a little bit. But we mean to take the logic to the client mainly and to do visualizations that render very fast with lots of colors, and you change symbolization very easily. I will put you an example video. This one. Okay. This is MapLibre, and this is more or less where we arrived with MapLibre. This is the metro of which city? You recognize someone? Barcelona. This is the metro of Barcelona, and you see the trains in real position, in real time, sorry. There's an API who serves the position like every 10 seconds or so. And we make these visualizations. Here are the panels that are also in the stations. And here you can see the occupancy. You see this yellow. It means that it's real-time occupancy of the wagons. Okay, and we have also this 3D view. Okay, with real-time. And in each wagon, you can see the height and the color is the occupancy of the wagons. I don't know if you can see it very well. More or less. Okay, so this is made with MapLibre, with 3D, with extrusions. It's not real 3D, but it's it does make this sense of 3D. And this is more or less where we arrived with only MapLibre. Okay, with the library, but we want to go a little bit further. Okay. We have clients, we have projects that want more dynamism. They want to change symbolization dynamically. They have data sets that are much bigger than this one, because this is a position of maybe 50 trains. Okay, in real time, every 10 seconds, but it's not a huge data set. So we have clients that want fast filtering in massive data sets, and with graphs synced with filtering, so you filter and you see the graphs changing and everything. So this is done by with Deck.gl mainly. In the right we have some technologies that we can use. And what we will see today is 4 cases, okay, of how we combine these technologies and more technologies that are not here to get this very fluent way of watching maps. Not the WMS click the tiles, the raster tiles of that help does a lot for a long time. But okay, so the problem, of course, is that you want to download a large data set and you want to render it in the client. First, you have to download it, okay? So that can be a problem. We will probably have to make some strategies and think a lot about it, because it's not easy to download a huge data set. We have to parse it, and we have to render it fast. So these are the challenges we will face in each of the four cases. We will have to cook a little bit the data, okay, differently depending on the cases. Okay, first case, it's urban files. We have a client. Do you recognize this island? Anyone? No? This is Menorca in the Balearic Islands. Okay, and the client, we work for them for a long time. He has the typical SDI with lots of layers, here more than 1,000 layers. And they have these urban files that they want an advanced visualization for them. They want to analyze the data, to be able to pan and zoom and the graphs and the charts have to change dynamically, okay? So what's the challenge here, technically? We have 40,000 points, but the data is dynamic, so we cannot make a static file or whatever. What we need to do is what I just said. We want to filter by bounding box, filter by year range. I mean the typical slider that you that you move, and the map changes immediately. And what do they want to see? They want to see the quality of service of these urban files. I mean, how fast they are solved and the quality of data. The first iteration was done with vector tiles and MapLibre for the base map and also for the urban files layer. Okay, and for the base map it worked very well, but for the data layer, it was not good because they wanted to see the 40,000 points at low levels of zoom, high levels of zoom, I never know, well, from far away, okay, and what means that at far levels of zoom, you download 40,000 points, and then when you zoom in, you download the 40,000 points again, so vector tiles are really not for that, they are for simplifying geometries. Okay, so the second iteration was more simple, to use a GeoJSON file. GeoJSON file which is faster, which is lighter, the data is not simplified, and GeoServer provides directly the GeoJSON file. So it worked very well, and at the third iteration we have this. We use Deck.gl to symbolize these density dynamic maps. I think I'll put also a very short video of this, just for you to see that it goes fast. Okay, the video is playing here. You see that when the viewport changes, the graphs are changing, okay? When you scroll, the graph are changing. And there's this button here to see aggregate data, so you can make the aggregations in the client. That's always the point, okay? Not to make anything on the server, but to have all the data with the GeoJSON and make there your cooking, okay? Okay, next use case. Biodiversity occurrences. Do you know what biodiversity occurrences are? Should be position of animals, okay, in the history. It's for the Museum of Barcelona of Natural Sciences. And they have like more than 100 years of animals everywhere, okay? That's 200,000 point features, okay? The data is more or less static, that they change it every year, but the GeoJSON is more than 400 megabytes, even compressed it's 25 megabytes. Why? It's what we want to symbolize here. It has a lot of attributes, like 80 attributes, okay? So with that, vector tiles are impossible, absolutely, and GeoJSON wouldn't be working. So what was the solution? To make a GeoJSON very light, a very light GeoJSON, to cook the data so that it's much, much lighter. We only use the attributes that we really needed, so less attributes. We simplified the coordinates because we don't care so much if the animal is exactly here or is 10 meters away, okay? And then we used a lot of dictionaries so that the attributes are used with integer values and then you go to the dictionary to see if the animal is, I don't know, male, female, if it's a fossil, if it's a non-fossil, whatever. And with that, we had less than 3 megabytes gzip, okay? GeoJSON of less than 3 megabytes. So it's really easy to download it at the beginning, okay? Yeah, to download it is easy, but to parse 200,000 features is not okay. It's not possible. It's very, very difficult, okay? And it was too slow. So we had to make something about that. And we decided to use Geo Arrow. Anyone was Geo Arrow here? Okay, some people. Okay. So we discovered Geo Arrow last year from Kyle Barron, his main developer in Firenze. So go to the Phosphor-G, it's useful, you discover new things. And what is Geo Arrow? It's a format that's super fast, experimental. GDAL supports it, Deck.gl supports it. He has examples of loading 1 million polygons or 3 million points. Just go to this to its repository, and it's really fast. How does it work? Well, the secret is that instead of building a GeoJSON, download it, and then parse it, and then send it to the GPU, to the graphical processor, you directly download what the graphical processor needs. You download the binary file directly, okay? This Geo Arrow allows that, and you download it and you send it to the GPU through Deck.gl. And it was the fastest thing to do. I think I can show live demo here. I don't know, we have the points here, the 200,000 points, and you can filter it in real time very fast, like, I don't know, we have even a play button. We can scroll, we can, whatever, put it in 3D, you can do whatever you want. You can even change the symbolization if you want, on the spot, or you can filter, or whatever, and the animation continues. You have all the data in the browser. So no need for servers, no need to go find the data elsewhere. I can even filter on the spot, and it works. Okay. How is my time, Ivan, more or less? What? 7? Okay, faster? Okay, Irriter, third example. Irriter, it's a project of the Agri-food Institute, and they have like a huge database where they calculate indicators for irrigation. Okay, so how much water they put on each plot, and predictions. This is the important part. Predictions of how many water they need for each plot. Okay. The problem is that they have 25,000 polygons, 25,000 plots, and a lot of data. I mean, they have 10 years of data, weekly data for 17 indicators. That means 1,000 data per year per plot, which means a huge data. So we cannot use GeoJSON or Geo Arrow things. They would be too big. It's gigabytes of data, okay? So what to do? Which strategy? In this case, the solution was to use vector tiles, but only for geometries. For the polygons, they work real well. You have the simplified polygons from far away and real polygons from higher zooms. And then there's the REST API where we download only the data matrix per indicator, so that it's 2 megabytes, okay, zipped, and it's convenient. Thanks to Deck.gl, then we create a function, okay, that it has this attribute, get fill color, okay, and you do a user-defined function, get feature color, that directly returns for each plot the RGB, number, the color, okay, the RGB code, so that you know how to paint each plot, okay? I do live demo, or I do, yeah, live demo. Okay, here we have the 25,000 plots. Okay, you see that it runs very fast. Okay, and you can see, you can analyze the data, you can even have this play button where you can animate this 25,000. Okay. Do we have very fast the fourth case? 5 minutes still. Okay, great. We will have to do a second version of this agriculture project, Irriter, where we will have 300,000 plots, so it will be another challenge. Last example, a client of mining topography. He wanted lots of things. He wanted a 3D terrain, he wanted point clouds, real 3D drawings, edition of 3D geometries, and that was the first time we saw that MapLibre couldn't handle that. So we had to use MapLibre and Deck together, Deck.gl, okay? We will see a video because I think it's easier that I explain directly on the video. It opens somewhere. Okay, sorry it's in Spanish. Let's advance a little bit. Here we have the terrain and we have the contour lines. You call it the contour lines in English? Contour. I didn't pronounce it well. Sorry, Ivan. So we have these contour lines. The contour lines are drawn by Deck.gl, okay? And the terrain is extruded by MapLibre directly, okay? So we combined the two things, the two technologies. And a lot of drawing capacities. Here we are drawing a line to calculate the profile, okay? And you see that when you put it on 3D, the line stays on the surface. Okay, you can view synchronized the profile and the line. Another feature is area calculation. We have the elevation model, so we can calculate how big is this kind of pile of material. So they want to calculate these volumes. And here, this is very interesting, it's the multi-profile. The multi-profile, we draw this line, and then you have profile all along the slope, right? And you see that's also interactive, and you have all the slopes here on the bottom left. Okay? And finally, to draw areas. They wanted also to draw 3D areas. On the floor, this is real 3D edition, so in this case it's not extrusion like in the trains, that was not real 3D, this is real 3D with 3 coordinates, okay? And here you see that the drawing we did was under the surface. The red spots mean that we are under the surface and we can accommodate and we can make calculations depending on the surface. Okay. So, we're almost finished. I think before the conclusions I have time to drink a sip of water. 2 sips of water or 2 minutes? Oh, 2 minutes, okay. Some conclusions. The first conclusion is that there's no conclusion. So that the best solution depends on many things. So when you have this problem, you have to make proofs of concept, and if it's a performance problem. So you have to make proofs of concept with different technologies and choose the ones that suit best. Okay. And another surprising conclusion is that sometimes the simplest well-known approach works well, like GeoJSON, directly download the GeoJSON. Sometimes it works, and you don't have to go further. And another conclusion, mainly of this last project that I show, is that Deck.gl and MapLibre work very well together. Okay, so usually MapLibre for base maps works perfectly, okay, and Deck.gl for painting and symbolizing really fast and animations and all those things, it's a perfect library, okay. That's what Deck.gl provides. For massive data sets, it's amazing. For true 3D, it's also amazing. And it has a huge performance, okay? New data formats, a powerful community. Okay, finally, just to recommend if you want to go to this website, you can check our website, but in Labs we put some of these projects that we have and these games that we play, and also big projects, but I think you will enjoy. Thank you.